Hi guys, welcome back to the Amazing RD Kids. Today we will be talking about logarithms. Okay, let's start by talking about exponents. Let's take an example of 2 to the power of 4, which is equal to 2 times 2 times 2 times 2, which is equivalent to 16. Now what about somebody changing it and saying 2 to the power of x is equal to 16? What is x? This is your main question. Now, we want them to have the same base. So we know from the previous example, 16 is equal to 2 to the power of 4. This means 2 to the power of x can be written as 2 to the power of, 2 to the power of 4. So x is equal to 4 because they have the same base. This is what a logarithm is about. It will output the exponent. So if we want to rewrite this as a log, we can say x, what we're trying to find, is equal to log base 2 of 16. 2 is the base, even in the exponent. X is the exponent, base, and 16 is the final result, or also known as the argument. Okay, now let's go over some examples. Log base 5 of 25 and log base 6 of 216. These are two common examples. Let's start with some basics. Okay, first, we want to find out log base 5 of 25. So let's say these are both equal to x and this one's equal to y. Okay. So, in other words, this is saying that 5 to the power of x is equal to 25. 5 to the power of x is equal to 5 to the power of 2, because 25 is 5 to the power of 2. So x is equal to 2. Now let's try the second example. 6 to the power of y is equal to 216. 6y is equal to 6 to the power of 3, because 216 is equal to 6 to the power of 3. This means y is equal to 3. Okay, now these are some complex examples that you won't see all the time, and they're more complex than the simple equations we just visited. So let's say log base 4 of 2, and let's take log base 3 of 1 over 27. Alright, so the first one, this is asking that 4 to the power of x is equal to 2. What is x? Now there are two ways of solving this. First, you can just visualize it. 2 is the root of 4. So this means that root of 4 is equal to 2. And if you recall that roots as exponents are 1/2, a square root, this means that x is equal to 1/2, because 4 to the power of 1/2 is equal to the square root of 4, which is equal to 2. Another way of doing it is to say 4 to the power of x as 2 squared to the power of x, which can be rewritten as 2 to the power of 2x. Now you have 2 to the power of 2x has to be equal to 2 to the power of 1, so 2x equals 1, and x is equal to 1/2. Alright, now let's take the last example. This example says that 3 to the power of z is equal to 1 over 27. If you recall, fractions can be rewritten as a negative exponent. So this can be 3z is equal to 27 to the power of negative 1. And 27 is just 3 to the power of 3. So this is 3 to the power of negative 3 is equal to 3z. So z is equal to negative 3. Now let's talk about another important concept. So we will talk about the change of base formula, which is log base b of x is equal to log base anything you want of x over log of the same base of b. Let's take a quick example. One easy one is log base 2 of 4. Because we know that this is 2. Because 2 to the power of 2 is equal to 4. Okay? So this can be rewritten as log base a of 4 over log base a of 2. Now you can just plug this into your calculator with a having base 10, because that's a natural logarithm. And you'll get the same result. Now let's go for a more complex example. Log base 8 of 16. Well, now it's way harder. It's not easy to just look at it and find the answer. So let's break it up into using the new property we learned. The base change formula is log of, we'll find the base later, of 16 over log base of 8. Both of these numbers share a base of 2. This will give you whole numbers. So 2 to the power of what is equal to 16? And 2 to the power of what is equal to 8? So this is really just equal to 4 over 3, because 2 to the power of 4 is equal to 16, and 2 to the power of 3 equals 8. Now, some of you might be curious about why the change of base formula works. Let's take b to the power of y is equal to x. So let's first take the logarithm of both sides. So log b of y is equal to log of x. And note that a logarithm defaults to base 10. Okay, now we're going to go ahead and rewrite this using the power rule, which we'll discuss next time. The power rule states that you can take the exponent here and put it in front of the logarithm. So this would be rewritten as y times log of b is equal to log x. Now let's isolate y. To do this, we'll divide both sides by log of b. This will give us y is equal to log x over log b. Okay, now you might ask, the change of base formula said that log base b of x is equal to log x over log b, and you can put any base you want over here. So to get this part, we will have to take the starting point, b to the power of y is equal to x, and rewrite it as the regular definition of a log, which is log. So we're trying to find y. So log base b of x is equal to y. Another way of writing b to the power of y is equal to x. Now since both of these evaluate to y, we can say log base b of x is equal to log x over log b, which is just the change of base formula. Alright, hope you stay tuned and enjoyed this video. Stay tuned for the next couple of videos on logarithmic properties. Thank you.